self-healing systems for years. What's actually different here?
Most systems don't heal, Natalie. Normally, this is where the war room starts. Calls go off, and five engineers scramble to find the logs. If the error matches something known, they react. If it doesn't, they stop. What we are building is different. The system doesn't just react, it understands the failure.
So, what are we looking at?
We've spent years writing if error equals X, then do Y. If pattern equals A, then trigger B. That works only for what we already know. But production failures are unpredictable. And when something new happens, scripts fail, systems escalate, humans scramble. That's where cascade failures begin.
So, the system isn't really healing, it's just reacting.
Exactly. It's reacting to the past, not understanding the present.
So, what changes?
We stop teaching systems what to do. We start giving them skills to load on demand. Instead of hard coding fixes, we define how the system must think before it acts. Think of the Matrix. Neo doesn't learn Kung Fu step by step. He plugs in and says, I know Kung Fu.
So, this is not learning, this is loading capability.
Exactly. A skill is a reasoning contract, not instructions, not scripts. A structured way of thinking applied at runtime. Only evidence backed reasoning. Instead of coding answers, you define a bounded thinking model so the system can handle unknown failures safely. A skill is not logic, it's governance over reasoning. It defines five critical layers. 1. Decision boundaries, what it can do. 2. Safety guardrails, what it must not do. 3. Analytical framework, how to analyze issues. 4. Generation logic, how to generate safely. 5. Explainability contract, how to explain what proposes. We are loading how the system should think.
Let's see it. Let's make this real.
It's a standard Tuesday morning at the bank command center. Our fleet monitoring is green across the board. We're in a state of normal operations. At 10:40 a.m., a fault is triggered. The dashboard instantly shifts to incident underscore detected. We have a Swift bridge fault, critical for international transfers. This isn't a minor glitch, it's a high severity event. Normally, this is where the war room starts. Calls go off, and five engineers scramble to find the logs. But here, the auto healing agent has already taken the lead. In under 60 seconds, it has detected the runtime fault, collected the stack traces, and initiated an AI driven analysis. By 10:43 a.m., the AI has diagnosed the issue. A efference data SON. Watch the timeline. The system doesn't just tell us what's wrong, it plans the fix. It generates a patch proposal and validates it against our safety guardrails to ensure the cure isn't worse than the disease. It then moves into the GitOps phase, automatically opening a pull request in GitHub with the specific code changes. Automation is powerful, but in production, we keep a human in the loop. Josh, our commander, receives the alert. He clicks Review GitHub pull request with his team. Josh returns to the command center and hits Promote to Prod. The system executes the deployment, verifies the health of the new pods, and at 10:50 a.m., just 10 minutes after the initial fault, the service is restored. the status returns to normal. No manual coding was required, no long running bridge calls occurred, and our slow budget was protected. This is the future of resilient infrastructure.
This is where traditional systems stop. Ours begins. Skill is framework. We can route the agentic reasoning flow, for example, 1. Detect, 2. Collect evidence, 3. Analyze, 4. Classify, 5. Identify root cause, 6. Plan, 7. Validate, 8. Create patch, 9. Test, 10. Promote. This is critical. The system is not jumping to a fix. It is following a strict reasoning pipeline. So it's not guessing.
No guessing, only evidence backed reasoning.
And what happens after it finds the issue?
It generates a fix plan, then creates a GitHub branch, raises a pull request, prepares test plus rollback plan. And here's the key: nothing goes to production directly. We enforce strict enterprise guardrails, never patch production directly, always require PR based review, always include rollback, always require human approval.
So it's intelligent but constrained.
Exactly. That's what makes it safe. This entire system stands on four pillars: explainability, every decision is transparent; auditability, full GitOps trace; guardrails, no unsafe actions; human in the loop, final control remains with people.
So what's the real shift here?
Simple. We are not building systems that react. We are building systems that understand, reason, and act within boundaries. When systems start fixing themselves, the real architecture is not code, it is how they think.